Hello friends, welcome back to another episode of Barely Working AI. In today's episode, we are going to do something special. We are going to use AI to create Pokémon music. The Pokémon franchise has some of the best video game soundtracks of all time. I dare say better than Undertale or Deltarune. Pokémon Explorers of Sky, in particular, probably has the greatest video game music ever produced. In my previous video on AI music, we used a pre-trained checkpoint to attempt to generate Deltarune and Undertale style music. However, although the results were good, it sounded nothing like the source material. To fix this, in this video, we are going to train our own AI, or at least fine-tune one for domain-specific generation. For this, we need two things: an AI neural model and data to train it on. First, let's talk about the data needed for this project. To train our AI, we need lots of MIDIs. As we only need MIDIs to train our AI, getting data for this project was not a big concern. We simply went to VG Music and grabbed anything with Pokémon in the title. Using this approach, we acquired around 165 MIDIs. Unfortunately, 165 musical tracks isn't enough to actually train a model from scratch. MuseNet, for reference, was trained on hundreds of thousands of MIDI files. But it is enough to fine-tune a model for domain-specific generation. Typically, in natural language processing, we train language models on lots of unrelated data so that they can acquire a good understanding of a language. Then we fine-tune them on task-specific data. We apply a similar logic here. If we have a pre-trained model, it would be very easy to adapt it to generate Pokémon music using our data through transfer learning. So, logically, the next step was finding a pre-trained model. Luckily, Museformer, Microsoft's attention-based MIDI-generating language model, comes packaged with a pre-trained checkpoint and compatible tokenizer. Museformer is a neural language model based on self-attention transformers, like GPT or OPT. We use this type of technology in pretty much all of our previous videos on natural language processing. Language models work by predicting the next occurring word in a sequence. Museformer uses the same fundamental logic, but with notes instead of words, allowing us to generate music instead of text. Now that we have our model and we have our training data, let's talk about some data normalization steps. To continue to train this model from its pre-trained checkpoint, we'll need to break down our MIDIs to the same token format used by our pre-trained model. Unfortunately, this model has a slight quirk. It was only trained to generate using 6 instruments. The model only considers grand piano, 8-bit square synthesizer, acoustic guitar, string ensemble, bass, and drums. Unfortunately, our MIDIs contain a lot more instruments. As this is the case, to use this model, we'll have to normalize our MIDIs by forcing all of our instruments into narrow tracks. We simplify our MIDIs such that all instruments conform to this standard. All piano instruments that occur in our MIDIs become the grand piano. All guitar-related instruments become the acoustic guitar. All strings become the string ensemble, and drums stay drums. But everything else is forced into the 8-bit square synthesizer, which I use as a wildcard instrument. This means all brass and wind instruments are now 8-bit square synthesizer. Which isn't great, but there really isn't a better option. I'm sure that won't come back to bite me. With our MIDIs in the correct format, we began training. We train on 155 tracks and use 10 for validation. We use the best performing checkpoint according to our validation set after training. This occurred after around 22 epochs. It did take a while, but at the end of training, we had a neural model capable of generating pretty high quality stuff. Using this model, I generated a bunch of MIDIs. I then chose the best 4 for this video. I put 3 of these MIDIs in this special sound front here, but the first track is rendered in the default Windows General MIDI sound front, because it sounded slightly better. If you want to try to put these MIDIs in a different sound front, they will be available on my GitHub. Now, without further delay, let's take a look at our results. As we could see, the tracks are pretty decent, and they definitely have a Pokemon vibe to them. However, there is one glaring issue with the music, which you'll notice if you check out any of the bonus tracks on my GitHub. The high-pitched square synthesizer tends to ruin otherwise perfect tracks. This wasn't great, but it is what it is. The way I normalized the MIDI data could have been handled a lot better in hindsight, but at the end of the day, the end results aren't too bad at all. Anyways, that's all I had planned for this video. If you want to hear the MIDIs and some rejected content, check out my GitHub. They are all on there. I might also upload the Museformer model too, or at least my custom checkpoint. So stay tuned for that. Anyways, have a great day. See you all in the next video.